Today we are going to learn how to factor polynomials. And the first thing we're going to do is work some puzzles. So in each of these diagrams below, we're going to look at this top number. Oops, just kidding. We're going to look at this top number. And then we're going to look at the bottom number, and we're going to try to figure out, please let me get the right pen size. We're going to try to figure out what two numbers can I multiply to get the 9 and add to get the -6. So in this case, I would put a -3 here and a -3 here because -3 times -3 is +9. -3 plus -3 is -6. So for the 4 and the 4, I would put 2 and 2 because 2 times 2 is 4 and 2 plus 2 is 4. And so on all of these, I think what I'll do is pause the recording, see if you guys can figure them out, and then in a minute we'll come back and talk about some of the answers. Okay, so on these are the answers. You can see that on number 3, it's -15 and 2, because -15 times 2 is -30. -15 plus 2 is -13. And then on the second row, -12 and 7 works for this one. -8 and 3 works for that one. -3 and -2 works for this one. I'm going to pause and let y'all finish this last row, and then we'll come back and talk about the answers. Okay, and on the last row, it was -15 and 1 for number 7, -15 and 5 for number 8, and 4 and 3 on the next one. And so on these next puzzles, probably we'll only do these top 3 or top 6. So I'm going to let you work these in your groups, and then we'll come back and talk about the answers. Okay, number 1 was -3 and 2. Number 2 was -12 and 1. Number 3 is 7 and 1. Number 4 is -1 and 8. Number 5 is -4 and -3. And then number 6 is -5 and -4. I'm just going to pull these ones up, and we'll just do these quickly, and then I think we have enough examples to carry us into our lesson. We'll just skip this page altogether. Okay, so we're going to use that information to learn how to factor our polynomials that look like this, x squared plus bx plus c. We learned the distributive property and we learned the FOIL method. This time we're going to go backwards from a polynomial into two binomials. So we learned that when we do FOIL, on these two binomials, remember FOIL is first, outer, inner, and last, we get x squared. The outer is 5x, the inner is 2x, and then the last is 10. And that becomes x squared plus 7x plus 10. So when we factor our polynomials, we're going to go from this step to this step. And so the first thing we're going to do, we're not going to do these by guess and check because there's a way better way to do it. We're going to make our same little puzzle that we just learned how to solve. We're going to put this number right here, and this number right here. And we're going to think of two numbers that when we multiply them together, we get 36, and when we add them together, we get 15, and those numbers are 12 and 3. And so that means if we do x plus 12, x plus 3, when we FOIL that out, we will get this polynomial right here, and let's try it. Front is x squared, outer is 3x, inner is 12x, and the end is 36. And when you add these two together, you get x squared plus 15x plus 36. And so this is the answer to factoring that polynomial. Remember, FOIL. So let's try this next one. The 24 goes in the top, and the 10 goes in the bottom. So I need two numbers that when you multiply them together, you get 24. And when you add them together, you get 10. And those numbers are 6 and 4. So when you factor this out, it would be x plus 6, and then x plus 4. And so let's try it. Front, outer, inner, and then the last one brings us to x squared plus 20, plus 10x plus 24. Check. So we'll do this one. This one is x squared plus 7x plus 12. We make our little x, put the 12 there, the 7 there, two numbers together, multiplied to get 12, added to get 7, and the answer to this then is x plus 4 times x plus 3. Check it. X squared, outer, 3x, inner, 4x, last, 12, x squared plus 7x plus 12. Check. Girls. All right. We also have to worry about positive and negative numbers, but honestly, if you just use what you know about adding, subtracting, and multiplying positive and negative integers, it will all work out. So there's nothing positive and negative about this one, so we'll just carry on like we have been. This is a 5, this is a 6, and I need a 5 here and a 1 here. And so the answer to this would be x plus 5 times x plus 1. Double check, x squared plus x plus 5x plus 5, x squared plus 6x plus 5, and I get the same answer. And then this one, same thing. Put a 9 right here, a 6 right here, that's a 3 and a 3, and the answer is going to be x plus 3 times x plus 3. X squared plus 3x plus 3x plus 9. X squared plus 6x plus 9 is a check. Okay, on this next one, we do have a negative, but it really won't affect the way we do it. That's 15. Right here is a negative 8. So I need two numbers. When I multiply them together, I get 15. And when I add them together, I get negative 8. So this would be negative 5 and negative 3. So my two binomials would be x minus 5, x minus 3. And when you check with FOIL, x squared minus 3x minus 5x plus 15, x squared minus 8x plus 15, check. And then this next one is x squared plus 8x is equal to 12. There's no negatives we have to worry about. I'll put a 12 here and an 8 here. This would be 6, and this would be 2. And the answer here would be x plus 6 times x plus 2. Checking it, x squared plus 2x plus 6x plus 12. X squared plus 8x plus 12 is what I started with. My answer is correct. This one has a negative 5. So we'll put a 6 in the top and a negative 5 at the bottom. This would be negative 3. This would be negative 2. And that leaves us with x minus 3, x minus 2, and to check it is x squared minus 2x minus 3x plus 6, x squared minus 5x plus 6, back to where I started. And then we have x squared plus 13x plus 42. We have a 42 in the top, a 13 in the bottom. This would be 7, and this would be 6. And so this would be x plus 7, x plus 6. And when you check it, x squared plus 7x plus 6x plus 42, x squared plus 13x plus 42, back to where I started. And the next one has a negative 13x in the center, but it really just doesn't affect our math. We put a 40 at the top, negative 13 at the bottom. So this would be negative 8. This would be negative 5. Negative 8 times negative 5 is 40. Negative 8 plus negative 5 is negative 13. And so our answer to this factorization is x minus 8, x minus 5. To check, x squared minus 5x minus 8x plus 40, x squared minus 13x plus 40. Check, we got the correct answer. And again, we just follow our rules, adding and subtracting and multiplying positive and negative numbers. So this one has a negative 20 up at the top, and in the bottom is just a 1. The coefficient of this x is a 1. We just don't write it. So in here we would have 5 and then negative 4. So our answer would be x plus 5, x minus 4. That leaves us with x squared minus 4x plus 5x minus 20 plus x minus 20. And we're back to where we started. This one has 2 negatives, but again, just make sure we write the negatives when we make our x. That's negative 18. That's negative 3. So I need negative 6 here and then a plus 3 here, and that makes it work out. So this would be x minus 6, x plus 3. And to double check, x squared plus 3x minus 6x minus 18, x squared minus 3x minus 18, and we're back to where we started. And then, getting close to the end on this one, we put a negative 15 here, a 2 here, this would be a 5, and this would be a negative 3. And so our answer is x plus 5 times x minus 3. X squared minus 3x plus 5x minus 15. X squared plus 2x minus 15. Check, back to where we started. On this one, we have an 8 at the top and a negative 6 at the bottom. Negative 4. Oops, a little too happy. Negative 2. Answer is x minus 4, x minus 2. Just to check, x squared minus 2x minus 4x plus 8, x squared minus 6x plus 8. And then on this one, we have x squared minus 8x minus 20. So When we draw our x, we'll have a negative 20 here and a negative 8. And the two numbers that work are a negative 10 and then a positive 2. And so our answer is x minus 10, x plus 2. To double check, x squared plus 2x minus 10x minus 20, x squared minus 8x minus 20. Check, back to where we started. Okay, and to prove that they are the same thing, you can show that the original polynomial and the factored form have the same answers when you plug in different numbers for them. So this, we're going to factor this out right here. That is y squared plus 10y plus 21. We'll do what we've been doing. Put a 21 here and a 10 right here. This is 3 and this is 7. So our binomial is x plus 3 factored out times x plus 7. Now, this next slide is going to show these numbers inserted here and here to prove that they're the same thing. So this is when we factored it out and we substitute all those different numbers. These are the answers that we got. And this time we're using the polynomial, the non-factored form. We're plugging in the same numbers and we get the same answers to prove that it works. Same, just a different example. Okay, and one last time, just to end, take the last number, put it in the top, middle term coefficient, put it there. This would be negative 6, this would be negative 5, x minus 6, x minus 5, x squared minus 5x minus 6x plus 30, x squared minus 11x plus 30. Check. We are back to where we started. Oh, last but not least, another example. 9, 10. This would be 9 and 1. So our answer is x plus 9, x plus 1. This, negative 27, negative 6. This is negative 9. That's a positive 3. So our answer is x minus 9, x plus 3. This is negative 32, positive 14, 16, negative 2. So our answer is x plus 16, x minus 2.